Welcome to Chapter 23 on animation. Now with animation there are a lot of things going on. You've got to put together an assembly that works, and sometimes you've got to make in-context relations, and you have to make sure that your mates are taken care of properly. Plus, then on top of that, there's all of the animation stuff that you have to do. So I want to go over a couple of those things very quickly here, because the chapter does cover everything in a lot of detail. What we've got here, and this is a file that's available in the download materials for you, is a chain with a couple of sprockets and a spring. Now the way this works with animation is that I've used a spring pattern, which is new in the last couple of releases, and it allows us to create a couple of links for the spring and then pattern the rest of it along a path. And then as the originals move, the rest of the pattern will move as well. Chains used to take us a very long time to do, and the chain pattern has really proved that quite a lot. That's how we created the chain. The sprockets were placed using sketch geometry, and so they're able to rotate at the centers of the chain path. The spring was created a little bit differently, and if we take a look at that, we started out, of course, with just a line, because you can sweep a single sketch without needing to create a helix. In this case, we have a circle that was swept along a straight line. And this straight line, you can see, has an in-context marker on it. So that means that the beginning of the line is constrained on the plane of the part, but the end of the line is constrained at the end of the chain. So as the chain moves up and down, this line moves up and down, and thus the sweep, or the swept spring, is going to move up and down as well. So that all happens with the motion. Let's take a look now at the motion study. Motion study tab is down at the bottom of the feature manager, and if you click on that, we get a new interface. Most of the tools here are self-explanatory, or they have tooltips that come up and show you what that particular tool is all about. What you need to know is that the time bar is this gray bar, and this can be moved back and forth. So when you place the time bar at a particular location and then locate a part at that time step, that's how the assembly will animate. Another way that you can do it is using motors, and that's one of the things I've done here. I've applied a linear motor to one end of the chain, and that linear motor allows the chain to go back and forth, which activates the in-context relationship on the spring, and it also makes the sprockets go around with a gear mate. These are all things that you should verify for yourself in tearing apart this assembly, looking at each of the mates that was used to create it, and in particular looking at how the spring was made with the in-context relationship. That's very important. There's some things that can be animated, and there's some things that cannot be animated. You can animate dimensions that have a distance or an angle, but you cannot change part dimensions with animation. You can get around that if you can create an in-context relationship between the part you want to have change shape, say our spring, and the part that you want to move, say a chain in this case. So if we hit play, you can see our chain goes back and forth, and the spring actually extends and compresses. You can record your animation as an AVI file. You can apply motors, springs, contact situations, and even gravity. This is not a simulation or FEA type tool. This is strictly motion, and it's not kinematics either. So if you give a ball velocity, it's not going to use momentum to keep it going. You can add gravity to the study, obviously, for any unconstrained parts. So animation can be a lot of fun. You can mix it with rendering and really have something that looks great when you're done. Best of luck to you, and we'll see you in the next chapter.